let us compute the derivative of the cosine of 2x. Notice that here, because there is the 2x, this is not the derivative that we have learned how to do. We know how to do the cosine of x, and we don't know how to do the sine of x, but that's it. The cosine of 2x, we need to learn something new. Okay. One possibility here, because it's the cosine of 2x, we can use trigonometry. Remember, the formula for the cosine of 2x is the cosine of x squared minus the sine of x squared. Okay, we could apply this. And here, remember that the cosine square of x plus the sine square of x equals 1. Okay, so we can write the cosine square of x minus 1 minus the cosine square of x. Okay. Why did I do that? Well, because now I have twice the cosine square of x minus 1, which is twice cosine of x times the cosine of x minus 1. And now I have a product of two functions that I know how to differentiate. So here, thanks to trigonometry, I will be able to do this derivative. So this is d dx, 2 cosine of x minus 1. Okay, the constant -1 doesn't matter because the derivative of -1 is going to be 0. So this is going to be twice the derivative of the cosine of x times the cosine of x. And here we can apply the product rule, and we get 2 times cosine of x times the derivative of the cosine, which is negative sign, plus negative sine of x, the derivative of the cosine, times the cosine itself. So what we get here is minus 4 sine of x cosine of x. And if you remember, the formula for the sine of 2x is twice sine of x cosine of x. Okay, so this is minus 2 times the sine of 2x. And this is the derivative for the cosine of 2x. Okay, there are several things, several takeaways from this computation we have done here. The first one is that even if we didn't know how to compute the cosine of the derivative of the cosine of 2x, thanks to trigonometry, we have been able to figure it out. Okay, but you must agree with me that this we did is very specific to the cosine of 2x. If I write the cosine of 2.5x, then it's not going to work. Okay, so we need a more robust method. One more thing I wanted to mention is that here there are the 3 trigonometric inequalities that we absolutely need to remember at all times. The formula for the cosine of the double angle, that the cosine squared plus the sine squared is equal to 1, and the formula for the sine of the double angle. These 3 we need to make sure we know. We will be using them once in a while. Okay. But coming back to the original question, we need to figure out some method that works for compositions. Compositions of functions. Okay, what do I mean? Well, in this case, I have the cosine of 2x. So this is a composition of two functions, right? This is f of g of x for f, which is the cosine of x, and g, which is the multiplication of x times 2, twice x, 2 times x. Okay, when I compose these two together, remember we say g composed with f. Okay, then I get my original function cosine of 2x. Now, one thing here, the order is very important, because if I do g of f of x, what I'm going to get is 2 times f of x, which is 2 times cosine of x, which has nothing to do with the cosine of 2x. Okay, so very important, order matters. Okay, more examples of compositions. Let's see. So this is our example 1. Let's do more examples. For example, let's say a composition of a power, x to the power 10, and then let's pick something linear, 3x plus 2. So here, when I do g compose with f, okay, always write down with the parentheses, this is f of g of x. So g of x, you take x, that's your input. G of x is the first output, which then is the input of a function f itself, and then it gives you a second output. Okay, so this is f of 3x plus 2 because of the formula for g, and then this is 3x plus 2 to the power 10 because of the formula for f. But if I do the other way around, I do f composed with g. In this case, I have g of f of x, which is g of x to the power 10, which is 3 times x to the power 10 plus 2. Okay, again, these are completely different. I could do many more examples, right? I could take the square root of x as f and the logarithm, the natural logarithm of x as g. Okay, and in this case, well, let's do different. Let's throw in one more function. Let's take h of x, x plus 2. Okay, in this case, I could do the composition h composed with g composed with f. Okay, and now I have 3 nested functions. So I put f outside, then g in the middle, and then h of x inside. Okay, and now it's just a question of patience. So we do the inside first. So h of x is x plus 2. Okay, then g of x plus 2 is the logarithm of x plus 2 because of the definition of g. And then f of the logarithm of x plus 2 is the square root of the logarithm of x plus 2. Okay. And now we could do the reverse. So we could have a function f of x, capital F, that is the exponential of x squared. And we may want to write this as a composition. So this is a composition of 2 functions, the exponential of x and x squared. Okay, written like this, f of x is g composed with f. Okay, so it's f of g of x. Let's do one last example. For this one, I suggest that you stop the video and try by yourself to write this capital F of x as a composition. Okay. Here we clearly have 2 functions. One is the outside square root, and then we have the inside x to the power 3 plus 1. Okay. This is not the only choice. You may have decided to do something else, but this is the simplest possibility. Okay. If I write like this, f of x is f composed with g, which is f of g of x.